Okay, so now we're on page 29, and we're going to do problems 4 through 6 using double angle formulas, because that's what 4, 5, and 6 are about. Before we can do that, however, we have to go back and review that we have to draw, according to the directions, our two triangles so that we can do this. So I'm going to use two colors. I have my alpha triangle in quadrant 2, and I have my beta triangle in quadrant 4. And based on the information on the problem, it says that sine of alpha is 3/5. Hopefully you remember doing this when you did problems 1, 2, and 3. And so this is 3. Oops. This is 3, and this is 5. And when you undo the Pythag, you'll get the square root of 16. Make sure you use the negative version because x is negative in that direction. And then it tells you that tangent of beta is -5/12. The x is going to be positive, the y is going to be negative. And then we're going to Pythag and get 13. So now that we have that picture drawn, and I'll label it, the red is my alpha, and the blue is my beta, I can go ahead and do these problems. So, number 4 says that I have sine of 2 beta, and using the double angle formula, that means that I have 2 sine beta cosine beta. And so I'm going to do 2 sine of my beta triangle is -5/13. And cosine of my beta triangle is 12/13. And literally all you're going to do is type that in your calculator the exact way it appears on the paper. So you're going to type 2 parentheses, make a fraction, -5/13, and then another set of parentheses and another fraction, 12/13, and press enter. And you should get that the answer to number 4 is -120/169. That is your answer to number 4. Number 5 is very similar, only it wants you to do, actually, hang on. Let me back up real quick. I'm going to do number 6 first. Number 5 is going to require, I think, a little bit of cleaning up. So I'm going to do number 6 first, and then I'll go back and do number 5 for you. So number 6, cosine. Okay, so now we're going to do number 5. And we have tangent of 2 beta. And this is going to equal 2 tangent beta over 1 minus tan squared beta. The beauty of this problem is that the directions already told you what tangent of beta was. It's -5/12, so we don't even need our triangle picture this time because we're just using what they told us. So I'm going to have 2 -5/12. Oh, it's like the worst 12 ever. Let me rewrite that. 12/1 minus -5/12 squared. And then we're literally going to type it in our calculator. So on top, well, first you're going to do a fraction, and then on top of the first fraction, it's going to be 2 times, put another fraction in, -5/12. Then the denominator, 1 minus, parentheses. It's super important in the bottom that you put parentheses because you have to square your fraction. And when you do, you're going to get -120/119, and this is your answer for number 5. So now we're going to flip the page over to page 30. And we're going to do problems 19 and 20. So now I'm on page 30, and I'm looking at number 19. And I need to solve, and I have right now cosine of 2x minus cosine of x equals 0. And so the 2x tells me it's going to be a double angle formula. You have 3 options in using double angle formula, and you can obviously try each one until you get something to work. But since it equals 0, I know that I'm going to want to factor. And since I know I'm going to want to factor, I'm probably going to want my cosine 2x to stay in the terms of a cosine only. So I'm going to take my cosine of 2x, and I'm going to replace it with 2 cosine squared x minus 1, and then I still have my minus cosine x equals 0. I'm going to rewrite this 2 cosine squared x minus cosine x minus 1 equals 0. I'm going to factor. I'm going to do a times c, which is going to be a negative 2. 2 factors of negative 2 that add and make negative 1 are 2. Negative 2 and 1. So I can rewrite this as 2 cosine squared x minus 2 cosine x plus 1 cosine x minus 1 equals 0. I can factor by grouping now. I made my two groups. My first group has a 2 and a cosine x in common, and I'm left with a cosine x minus 1. I can pull out a 1 in the next group. I'm left with a cosine x minus 1. My two groups now both have a cosine x minus 1 in common. In my first group, I have a 2 cosine x, and then I have a plus 1 for my second group equals 0. And then I'm going to set each piece equal to 0. So when I set each piece equal to 0, I'm going to have cosine x minus 1 equals 0, and that means that cosine x equals 1. Based on your restriction, we know that happens at 0 and at 2 pi, but 2 pi is not included in the restriction, so x equals 0 radians. There's one of my answers. And the other piece says 2 cosine x plus 1 equals 0. So that means cosine of x has to equal negative 1/2. That happens at the second and the third quadrant. So 2 pi over 3 and at 4 pi over 3. And those are the answers for number 19 on page 30. For number 20, I have sine of 2x plus cosine x equals 0. Sine of 2x only has one possibility to replace it with. So sine 2x becomes sine of 2 sine x cosine x plus cosine x equals 0. Again, we're going to factor. They both have a cosine x. I'm left with a 2 sine x plus 1. So each piece equals 0. Cosine of x equals 0. And sine of x is going to equal negative 1/2. For this one, we just did, it's 0 radians. And for the other one, sine equals a negative 1/2 in the third and the fourth quadrant, so 7 pi over 6 and 11 pi over 6. And there is your other two answers. So now you've done problems using your double angle formula, and hopefully you've been very successful.